Bom, são 14h30, vamos iniciar o nosso webinar, que vai ser dado pela Foc, que é uma empresa alemã, que vão se apresentar, vai falar sobre monitoramento de rede óptica. É um assunto extremamente técnico, acho que de interesse dos profissionais do setor de utilities, e a UTC está muito feliz em colocar este assunto em pauta. Nós teremos a apresentação pelo lado do senhor Christian Kutzer, que é o presidente da Foc, e também Hans-Dieter que fala português. Nós teremos uma apresentação mista em português e inglês, mas os slides estarão todos em português. Vocês podem fazer as perguntas necessárias para no chat ou nas perguntas e respostas, e nós avisaremos os nossos palestrantes. Então, nós teremos em torno de 40 minutos de apresentações. Logo depois, teremos perguntas e respostas. Espero que seja de interesse de todos. Eu passo a palavra, então, para o senhor, eu acho que é Hans, que a gente vai falar, e depois vai falar o senhor. Ok, Hans, é com você.
Ok, tudo bem. Boa tarde. E o nome Hans mais fácil como poeta. Also, boa tarde, senhor Weissmann. Boa tarde para todos. Seja bem-vindo no webinar entre Brasil e Berlim, da Alemanha. Quase nós fazemos um webinar bilateral. Mas só uma pequena coisa, aqui um pouco mais frio como no Brasil. Hoje temos só 0 graus, mas um pouco frio aqui. Estamos ansiosos pela sua participação aqui. E muito obrigado, senhor Weissmann, para a organização do webinar e muito obrigado pela presença das empresas interessadas. O meu nome é Hans-Dieter.
Eu vou pedir para colocar de novo a apresentação. Eu estou vendo uma tela preta, não sei como o Márcio está vendo. Tira a apresentação e coloca de novo. Vamos ver se vai.
Nochmal die Präsentation an.
Ok.
Ok.
Bota em tela inteira agora. Full screen. Yeah. Good.
Agora está ok?
Ok.
Ok, a técnica. Also, mais uma vez, meu nome é Hans-Dieter. Eu sou representante da FOC e também sou vice-presidente do Centro Empresarial e Científico Brasil-Alemanha e também eu membro da iniciativa Alemanha-Brasil para a cooperação em agronegócio e inovação. Nós temos hoje o sistema de monitoramento para redes ópticas. E você sabe, o sistema de monitoramento já existe há alguns anos, mas a FOC é a única na Alemanha com um novo sistema, a única no mundo. Quase a FOC é uma empresa alto nível. E agora eu vou falar um pouco palavras, senhor Kutzer.
Hello and good evening from Germany. My name is Christian Kutzer. I am the founder and CEO of FOC here. FOC is a medium-sized company, is working on the market of telecommunication and data transmission via fiber optic. And I'm very happy to be here this day and to show you the last steps and the last innovations about safety and security in data transport. And I hope it will be interesting for you, and we will show you our system. We will describe our system, and I hope you can understand my English description of the system. If you have any question, please feel free to ask Mr. Boltan, because he speaks Portuguese, and I guess it's more easier for you.
Sim, nós fazemos quase uma mistura de línguas. E primeiro vamos mostrar uma curta filme sobre a empresa e depois o Kutzer vai fazer a palestra. A FOC é uma empresa de novas tecnologias de fibra óptica, sede em Berlim, Adlershof, quase no maior e mais moderno parque científico e tecnológico da Alemanha. E aqui você pode ver o novo prédio da FOC com administração e produção. O prédio é propriedade da FOC, foi abrir nesse ano em maio. E aqui parte da produção, pequena parte da produção, e a FOC trabalha quase em dois turnos. É uma empresa líder em produção, tecnologia, com vendas, pesquisas e desenvolvimento de produtos próprios, além de aplicação prática nacional e internacional. Sim, e agora você tem uma pequena firma sobre a FOC, e agora o senhor Kutzer, o CEO, vai começar com a palestra.
So, from my side, a short talk about the history of FOC. FOC, the foundation was in 1993. From my point of view, it's a young company, except CEO. And from this year, 1993, FOC starts as a producer of fused couplers, and then about a lot of steps in the market of telecommunication. FOC is changing a little bit from a components producer to a system vendor to a solution provider. In the last steps, now in 2020, FOC moved to this new building. You had seen it in the small video. And today, FOC is manufacturing a lot of connectors on the highest level. That means without, or it was ultra low loss. Then we have main and sub-distribution systems for core networks or for FTTX applications, or also for industrial and railway applications. We are producing filter and splitter modules. We are a vendor of complete FTTX system solutions. FOC has, as Mr. Boltan told you, development also for the software of the monitoring system, and actually we have something more than 55 employees, 4 national offices, and we have 12 international partners. A more technical view on FOC. From the beginning of 2007, we decided to develop a new basic technology for making the components smaller and to give them more flexibility and capacity. So you see, we developed a polymer board technology with 1x1 structure, next step 1x2 structure. Then we had small form factor coupling possibilities, and today we have complete modules. Then here you see the products we could sell to the market. In 2014, we could sell the first FTTX Linux reflector. That's a basic component for our monitoring systems. Sometimes later, we put the class A connector to the market. We need this connector in systems where we integrate a monitoring system, and our focus was there to drop down the additional access loss. So then, some 3-4 years ago, we put to the market and some sensors. One sensor is an opening sensor. It's like a passive optical switch. Also here the focus is everything passive only with light without electrical current. And today, and this is we want to show you, we have our one monitoring system on the market, and you see the way FOC has gone is from a components manufacturer to a passive infrastructure and security system vendor. Monitoring, there are some steps of monitoring. I guess a lot of you know this OSI model. There are a lot of layers in a data transmission system, and our monitoring system is focused on the physical layer. That means we want to monitor the fibers, we want to monitor passive components, and we want to monitor some passive equipment around fibers and couplers and filters. That means we want to monitor enclosures and street cabinets, manholes, and so on. From our point of view, this monitoring should be a monitoring which works or give you on time an overview about your network. That means, can the network work without disturbance? And it should be work automated. That means all reaction you have to do in a case of a failure or an error or whatever should be managed by the system automatically. And the system also should work in active systems, in dark fiber systems, independent from the network strategy, and from the network scheme. That means it should work in point-to-point networks, it should work via cables, and it should work in passive optical network structures. Below you see some references we had in the past. Even the system is rather new on the market. We have some international, very interesting projects, and I will come to this topic later. The basic idea, I guess it's only to remember for everybody, monitoring based on an OTDR measurement technology is not a new technology. We use this OTDR technology, we feed in the wavelengths of this OTDR, that means the wavelengths in the range of 650 nanometer, upside from the data stream, and this wavelength is transported through the fiber parallel to the data stream. And at the end of the fiber, we install a very small reflector. This is this Linux reflector. And this reflector has to do a hard work because all the energy and the wavelengths of this OTDR has to be reflected. If we don't have such a reflector, then the signal of the OTDR comes to the receiver of the client or of the customer equipment, and then there will be a lot of disturbance and the system can't work. That means the reflector should reflect nearly 100% of the wavelengths of this OTDR. This is a basic structure, and very important is that the system, I told it, works automated, that it is quick and easy, and the whole network, the whole passive components of the network should be under control, independent of any active equipment. I guess everybody knows this OTDR technology can monitor fiber by fiber. The question is, if you have a lot of fibers and you want to install a monitoring, you need a lot of time to monitor every fiber. You see, if you have 1,000 fibers, you need the measuring cycle time 1,000 times of one fiber. If you need a measuring time of 1 minute, you need 1,000 minutes to monitor a system or a network or a cable with 1,000 fibers. That is not an on-time monitoring. A very good idea could be to switch the monitoring signal parallel in all fibers. But what a pity, if you do this, then you see only a noisy picture on your OTDR. That means a parallel measurement, very good for monitoring, is impossible for this OTDR technology. We have described it in this picture. The OTDR is fed into the fiber. It goes to a passive splitter 1/n, and you can't see the signal behind the splitter. And the question is it possible to organize or to realize a parallel monitoring? If we come to the next picture, you see every line after the splitter for the monitoring is clear. That means we have installed the reflectors I described before, and every reflector is reflecting one signal, and every reflected signal is related to one peak or one needle on your OTDR. This is a basic step of an on-time monitoring. That means we can feed in the monitoring signal parallel in all fibers. Every reflector at the one hand side is protecting the end device, and at the other hand side is creating a reflex, and every reflex is connected or related to one fiber. And so we have a very, very good result because we can monitor lots of fibers parallel. What steps do we have to do, or what components we have to integrate? We have to integrate in the system this reflector. This reflector is very, very small. You see here a picture of the size of these Linux elements. It's very, very small, and so we can integrate the reflector we need for our system into a ferrule of a connector, or we can integrate it in a small pipe or whatever. We can use this Linux technology also for the needed WDM, these multiplexing elements. if we have 1,000 fibers, you can imagine we need thousands of these WDMs, of these multiplexers. And if we can realize these WDM or these multiplexer in these small sites, we don't need any additional units in your system. We need, or we use for the system, for the integration, our class A connector, because every connector, every additional connector brings additional insertion loss, and insertion loss is not needed in networks. And so the additional system works with class A connectors, and this connector has an attenuation below 0.1 dB. That means we don't put so much attenuation in your system when we install a monitoring system. Then I described we have a lot of sensors. Today we installed systems with a sensor which detects the open and closing of manhole shutters, of doors, of street cabinets. And parallel, we have a water sensor. This water sensor detects if any enclosure or manhole is flooded with water. And at the end, we have a software. This software is transmitting the measuring signals into a system where the technicians on duty can see and realize what problem happens at what position. You see the complete or the monitoring system has a modular structure. It is applicable for point-to-point or point-to-multipoint network structures. You can monitor active dark fibers, and we have an outside plant surveillance. These features are very important for the project. You see on the bottom, for instance, we have in the URA, there was a surveillance system for the highway between Abu Dhabi and Dubai. And there we installed this monitoring system, and this monitoring system supports the cameras. We also had installed a system for the German telecom. We will discuss it just later. If we have installed such a system, it is not usable that everybody has a look at an OTDR. It makes no sense. That's why all signals sending from the OTDR measurement clusters goes to our system, and the system is changing the signals from the measuring signal to a system with a GIS functionality. And via this GIS functionality, you have all 30 seconds an overview about the network, of the fiber network, and you have a relationship between the way of the fibers and the structure of the city, or the structure of your industrial area, or whatever. Here you can see some pictures of our one monitoring systems. You see here, this is a 5G equipment. Here you see there's an enclosure in a manhole. Here you see a passive optical switch installed in a street cabinet. And at the bottom, it's a rather small element, it's like a thumb. That's the water sensor. This water sensor you can install, for instance, in enclosures or in manholes, wherever you want. This system, as described, is monitoring the optical fibers as the optical path, and parallel with the same system, with the same software And with the same GIS system, you have a surveillance of all outside plants. You have a water detection in manholes, in outside plants, and whatever. That means with one system of monitoring, you monitor the optical path and the surveillance of the optical outside plant. Let's have a look to the structure. The basic structure of the system comes from telecom applications. We have in this network, for instance, a central office. In this central office, the signal goes to street cabinets, to buildings, or to flats. And our system can work up to the first distribution cabinet. This may be a demarcation point, and it can go step by step to all network structures up to the customer. If you go back the way from the telecom system to an industrial application, there are similar structures. You have distribution points or cabinets, you have some demarcation points, maybe there are some local loops, and there is a terminal equipment or a sensor or a camera or whatever. Our one monitoring system is not only a system which can work with, for instance, in a city area or in a small industrial area. Our system consists of a lot of measuring clusters. Every cluster is a monitoring in its own. There is an RTU, there is a switch, there is software, and whatever. If you have a monitoring, or if you want to monitor a system, a land-wide system, then it's possible to install lots of these measuring clusters. Every cluster can work as a single station, but all signals are put together to a front end. This front end, it's a software. This front end controls every cluster, controls every active equipment. This front end is collecting every measuring values, it's collecting every alarm, and via SNMP is connected to the front end, the GIS system or a management system or whatever. That means by installing this monitoring system, you can work regional, but you can feed together all measuring values, all information from the whole country to a front end, and this front end is operating in a network operation center or whatever. The functional groups of this monitoring system is the monitoring software. This monitoring software is working together with the RTU. That means RTU, that's the OTDR. And this OTDR sends the signal to the parallel interface module. This parallel interface module is this module which feeds in the measuring signal from the RTU parallel in all fibers. If you have a dark fiber system, then this measuring signal goes up to the reflector and comes back. If you have an illuminated or a working system, then we have, after this parallel interface module, we call it connection assembly group. This is like a multiplexer group. Here comes your payload signal and goes through the cable or through the fiber up to the customer or to the sensor or to the camera, whatever. These are the groups of our system. Here you can see it in picture. We have here the OTDR, that means the RTU, including the software. We have here the parallel module. We have here the assembly groups, that means the multiplexing group. Here you can't see it. Inside is a reflector. For instance, in the ferrule, in the last pigtail, we can integrate it in the last patch cord or in a breakout cable, whatever. Then you see here the heavy duty switches to switch the doors or to switch the shutter of manholes. Here in this picture we have a system scheme of hard and software, and I hope you can see and understand how hard and software are working together. Here with this yellow or green color you can see the system. This can be a cable, this can be a FTTX system, an industrial application, a sensor system, whatever. At the end we have here our reflectors, and this system works together with the RTU, with the software we call FLIP. This is one measuring cluster. If you have lots of these clusters, you have to connect them with the front end. This front end is, for instance, in your network operation center. The way the data transport from the FLIP to the front end is via encrypted way. We deliver, if it is necessary in your network, a router system with a very, very high standard of data security. Then here in your network operation center is working the front end. The front end collects and controls every signal from the system. The front end is corresponding with, for instance, if it is existing a third-party network management system, the front end is corresponding with the GIS system and with a system which is focused for network management engineers. That means here they can see only the kind of failures, only the areas where the failures happened, and if they go into the software or if they go deeper in the system, they can identify the failure at which location, at which time, what happens in which measuring cluster and whatever. And I just described it, the network, the front-end system is also controlling the alarm system, and this alarm system can send emails, SMS, emergency calls, and whatever. This is a whole system working together, and FOC is selling, FOC is selling the software for the front end, the measuring cluster, hard and software, the GIS system, the front end system, and the system and the alarm system. At the next picture, you can see a detail of an existing network. This is a GIS-based picture, and you can see the way of the cables, you can see some manholes and some other things. In this case of a failure, the color of the cableway or of the fiber is changing. You can adjust 4 levels of threshold. The color black means there is a total defect. That means there is no signal from here, or maybe here is a shutter opened or a door opened. And on the left-hand side of this picture, you see the automated generated trouble ticket. There's a description of the error. There's a description of the endpoint. Is it a fiber? Is it a sensor or whatever? Then some information about the fiber. And at the end, we have the information which RTU is generating this information, because if the technician on duty receives this information, he can go to this RTU, and then he can do some measurements on demand. That means he is, for instance, in his office, and at the end, he can manage from his office and measurement on demand to this fiber, to the sensor, or whatever. I want to make a summary of the benefits of this one monitoring system from our point of view. All building blocks of this technology comes from one hand. That means the responsibility is very clear in the hands of FOC to the whole system. Because we use Class A connectors, we don't bring more loss into the system. That means we don't change the basic values of your system. We use this Linux technology, and with this Linux technology, we can reduce the space, for instance, of this couplers and multiplexers and some other things by the factor of 50 or 100. That means you need an additional space, but not so many space as you would calculate it with standard components. The summary of the USPs of this one monitoring systems: we have a reaction time for the information of the whole systems in a reaction time of 30 seconds. That means every 30 seconds you have an overview about your whole system. Is a fiber system working? And if is there any attack to enclosures? Is there any attack to manholes, to street cabinets, and whatever? It is very easy to identify and locate cable breaks, interruptions, regardless of installed components. That means if you have a network and a third party is using this network, you have a full overview about all passive components of your network. You have a real-time and automatic fault detection SNMP interface. It is fully web-enabled, and there's a graphic user interface installed. At the end of the day, you can reduce the installation time and the maintenance cost by testing and monitoring your system 7/24, and it is scalable up to a distance of 120 kilometers from one side. That means if you build up a monitoring from both sides, you have a direction or a distance up to 240 kilometers. This monitoring system has no interference with the data stream. That means you have the full capacitivity of your data stream and your transmission. And if there is transmission of very protected data, there is no touching to this data. The integration of the surveillance of outside plants, manholes, network equipment is integrated, and you have only to install one element. And there is no radiation, no electrical power supply necessary. I guess sometimes it is a problem, the intentional theft of cables or equipment, and I guess the reaction time of 30 seconds, there you have a good change to touch the person who wants to theft cables or equipment. Each peak is associated with a reflector. That means you have an evaluation of the line attenuations from the peak height. And so you can, with a remote functionality, measure the functionality of every fiber. It is, from our point of view, a cost-efficient assembly process. There's GIS-based a network map. It's very easy to design, and that's the German technology and the German software. That means there we have no, we integrated no software from outside Germany. A very important question, the invest of a monitoring system costs something, but the question is, there are also some financial benefits of a monitoring system. And to answer this question, we could look to an installation in the network of the German Telecom. This installation is working since 2 years. And the German Telecom had an overview about the potential of this one monitoring system and the results of the system from the German Telecom. The cost saving potential is 25 up to 35% in the event of damage. That means to identify the location, to identify the kind of failure reduces the cost for an event of damage, for a service event in the range of 30%. Approximately 15% they could reduce the cost through preventive repairs. That means via the system, via the one monitoring system, you can identify some processes where the transmission gets more and more down, and you can organize preventive repairs. Over 50%, and I guess that's a very important thing, they could reduce the cost in an event of fault being assigned, because the question is, do we have a failure in a cable system or at the active devices? And with our monitoring system, you have a clear overview about the cable or the fiber system. And if the fiber system is working, then it is very easy to decide there is no necessary to send a cable guy to this failure. Then it is necessary to have a look at the active technology or active device. And at the end of the day, the availability of the cable system is increasing by 20%. I guess there are some very good arguments from a very big telecom provider, from a network owner, and I guess the cost saving potential is very strong. Now is the question, is it possible to transfer the technology and to Brazil, how to organize to learn more about a system? Is it possible to organize a pilot system? And this question can answer you, Mr. Reuter.
See, uma coisa muito interessante, projeto piloto, mas nós queremos desenvolver projeto piloto no Brasil, para o mercado no Brasil, em cooperação com uma empresa brasileira, porque você sabe, para abrir o mercado, é muito importante, você tem que mostrar como funciona a nova tecnologia. E por esse caminho, quase nós queremos organizar uma transferência de tecnologia da Alemanha para o Brasil. E também é interessante, você pode ler aqui, os custos são menos, as eficiências mais altas se você começa com um projeto piloto para entrar no mercado. Mas, mais uma vez, temos um grande interesse em cooperação com uma empresa brasileira para desenvolver, para construir um projeto piloto. E, no fim, também nós queremos convidar as empresas interessadas para visitar essa lab em Berlim. Claro, depois da pandemia, no momento temos um problema com as viagens, mas essa lab, quase todos os processos podem ser definidos neste espaço, neste lab, como no original. E quase um bom lugar para aprender sobre a tecnologia de FOC. Mais uma vez, nós queremos convidar pessoas interessadas para essas duas coisas, projeto piloto e a visita em Berlim no FOC.
So, thanks for your time. And now, if you have some question, we would like to answer to your questions.
I have a question. I will do it in Portuguese, so we will translate. Sobre esse projeto piloto, como vocês pretendem fazer isso? Há uma especificação, uma proposta, porque podemos fazer interface com várias empresas brasileiras, mas é necessário ter um documento base para a realização desse ensaio. Então, eu queria saber se isso pode ser fornecido para que possamos discutir isso.
Please let me answer in English. The steps to come to a pilot project are not so difficult as it may be, as you feel it. The first point is to identify a network area or a network area, and to identify, do you want to monitor fibers? Do you want to monitor some manholes, some shutters, some doors? That means the definition of the functionality. That means a very small sheet of paper. We want to monitor 15 fibers or 60 fibers, whatever, in a length of X kilometers. Then we want to monitor 80 enclosures on this way. Then we want to monitor 15 manholes with every manhole with 2 shutters. And then at every station, we have 4 stations, 7 doors. That's the first point. And with this information, we could create a basic offer, a budget offer, which components you need, and which basic price level you have to calculate for the material. Then the project, if you say, oh, it's interesting, the price level is interesting, then we can make you a description of the system, and at the end of the day you have a bill of material with some prices. Then the next step is the training for your personnel to work with the system, or you say, no, I don't want to work with the system, please control it from Germany. You know, the connection to all over the world is stable, and we could also control the system here from Germany. The installation of the system is everybody in the hands of companies from Brazil. I guess it's not necessary that comes a man or a person who is splicing fibers from Germany and Brazil. That's nonsense from our point of view.
Okay. So I can expect from you a kind of questionnaire for utility or companies associated to UTC that can be interested, and if they are interested, they have to list what they want to monitor, how many fibers, how many blockers or whatever. So if you can send it to me, we can work from that point on with our member.
I guess that's a very good idea. We will send you a small list, a small questionnaire with not that are not 10 pages or so. It's only 1 page with some basic questions.
Okay.
And I guess to create a project, it's very easy to fulfill.
Okay. Do you have another question? Do you have structure in Brazil to maintain, to service this kind of installation? Do you have representative? Do you have people in the country to do this assessment of maintenance of the system if necessary? How do you work here?
Our idea, and I guess you could see, we installed some systems in Emirates and in other countries all over the world, in Tehran, and the idea of FOC is to make a small or a little or bigger technological transfer. That means the software comes from FOC, the basic components come from FOC, and then everybody who is interested in this one monitoring system, then we can do a training. If we have this corona phenomenon more in our hands, we send some specialists to, for instance, to Brazil. If this is not possible, we can do it via this web systems, and the basic idea is to give you a training that you can manage and that you can work with this system on your own base of knowledge. That's the basic idea.
Okay.
And at the end of the day, we can send some specialists. Of course, everybody likes to come to Brazil. And but at the end of the day, our idea is not to send some 10, 15, 20 guys from Germany. We can send some 1, 2, or 3 specialists for a training, and the installation and the working with the system. And the first step is in your head. And
Thank
this,
you.
This training is included.
I have some additional questions. The question is it possible, I will go in English, because the question was in English. Is it possible to monitor active fiber or only dark fiber? How does it proceed to monitor active fiber with Raman, for example?
This monitoring system, as I tried to describe, works on a wavelength of 1650 nanometers. This is a range reserved by the ITU only for monitoring. And we feed in this monitoring signal with a WDM or multiplexing, passive multiplexing element. And our monitoring system is transmitted parallel to the data stream. That means there is no mixing. And because we do it in this way, we don't know if there is a signal on the fiber or not. If you want to use a reserved fiber for the monitoring, you can do it, no problem. If you have no free fibers, if you say, I have only 10 fibers and I need them for data transport, no problem. We put in this multiplexer, and via this multiplexer, we fit in as a monitoring signal, and the monitoring signal don't touch the data stream. You have the full data transmission capacity.
Okay, so it can be used in dark or active fibers. Another question, now in Portuguese, so Hans will have to translate it. Este sistema pode ser utilizado em loops de fibra óptica que utiliza EDFA/moduladores? Outra pergunta, se ele quer saber se ele pode medir até 120 quilômetros de fibras ópticas, correto?
I try to translate it from Portuguese to English. If the answer is not focused on this question, please ask again. If you have some active equipment in your optical way or whatever, for instance, ADFAs and whatever, then we would install like a bypass. That means we bypass the active device, because we can't transmit this optical amplifier, can't amplify the monitoring wavelengths that work in another wavelengths. That would be a blocker. And so we install a bypass, and by installing this bypass, we have every time to focus, no more space and no more attenuation. That's why it is so important to drop down the attenuations of all additional elements.
Okay, thank you. There is one question that you have to read. It is on chat, because it is in German. So it's all for you. I don't know what the guy is asking. Ralph Arne Hope.
Ralph Hoppe. Ralph Hoppe.
I don't know what is the question.
Ok, não, tudo bem. Nós conhecemos, está tudo ok.
Então ele só estava cumprimentando vocês, ok.
Ok, obrigado de volta para ela. E também a mesma coisa para o senhor Untitled também, a mesma coisa. Muito, ok.
Ok, com isso nós podemos encerrar, nós vamos encerrar esse webinar, já está no tempo correto de encerrar, muito obrigado, foi uma experiência interessante. Eu queria... Márcio, tira essa tela, coloque só o vídeo das pessoas. Vocês podem agora encerrar isso, podem se dirigir ao nosso público.
Ok, also mais uma vez, nós agradecemos muito sobre a possibilidade e também sobre as participantes interessados. E na última palavra, e o nosso foco, nós queremos construir até no próximo ano, no fim do próximo ano, quase uma empresa de FOC no Brasil. Ja? Sim, ok. Mais uma vez, senhor, para todos os participantes, muito obrigado E até a próxima, se nós podemos viajar, vamos participar no congresso do UTCAL, vamos participar. É um congresso muito interessante e muito bom, organizado. O senhor Kutza já participou antigamente. E mais uma vez, muito obrigado.
Well, thanks for the possibility. Well, thanks for your attenuation, and I would be very happy to come to Brazil and to take more and more discussions. Even or so long it is not possible, please feel free to contact me via email or whatever, and I would be very happy to go this way step by step with you.
Okay, our next summit will be on August 24 to 27.
Okay.
We put it in the second semester. As you know, now the vaccine is starting in England, and I believe it will be starting all over the world. And I hope that in next year, in the middle of the year, in August, we will be able to have our conference. Thank you very much for a very good presentation.
Thank
Bye.
you.
Muito obrigado. Thank you very much. Tchau, tchau. Obrigado. Tchau, tchau.